Okay. What I've decided to do, obviously, since I have a stupid training this morning, I'm obviously not going to be in class today. So what I figured I'd do, let's kind of get this ball rolling. I'm going to give you a video. Hopefully it helps on how to do these last 3 word problems. I'm going to kind of teach you through this, see how it goes. Any questions, comments, concerns that we have. Either come see me in Pyramid today, I should be back by that time, or we'll talk about them in class tomorrow. I'm obviously pushing the quiz until Monday, so no worries there. Alright, so let's kind of pick up where we left off. Letter H, yesterday, we got to the point where I think we had drawn our picture a little bit better this time around. There is our picture. And we got to the point where we were talking about the cross-sectional area. So cross-sectional, obviously we want to find the best dimensions where we're going to maximize our area, which the volume can flow freely, the air can flow freely through our air duct. So here's the advice that I would give you. Start by labeling those two sides X. We don't know what they are, so I'm going to label them X. So if you think about it, I have 48 inches total. If I know those two sides, I know what I can do to figure out the remaining two sides is take the total minus those two sides. So I'm going to take the 48 inches total minus the left side, which is X, and minus the right side, which is also X. But notice that I still have two sides left to enclose. I have this side here, and I also have this side here. So because I have two sides left, I think what I need to do is take my 48 minus 2x, and I need to divide that by 2 because I have two sides left. That means that each side is going to be 24 minus x. 48 divided by 2 is 24. 2x divided by 2 is 1x. So each side is going to be 24 minus x. So it talks about find the maximum cross-sectional area. So I know area is length times width. So I'm going to take the length and the width. I'm going to put that there. And now I'm ready to find the maximum cross-sectional area. How am I going to find the max? I think what I'm going to do is put this into my graphing calculator. So, if I go to my calculator, here it is. If I go into y equals, notice in my y1, I typed x times 24 minus x. There it is. I'm going to hit zoom 6 because I always want to start with a standard window. Okay, so it looks like there is my picture. Looks like my Y max needs to get a little bit bigger. So I'm going to go into my window. I'm going to change my Y max. I don't know, maybe I'll change it to 100, see where that gets me. Nope, looks like I'm not large enough yet. So maybe 200, see where that gets me. Alright, looks like that's going to be high enough, but it looks like my X max needs to get a little bit bigger. Maybe I'll make this 50. See where that gets me. Alright, it looks like that's going to do it. So, if you remember, it asked us to find the maximum area that we can enclose. So, I'm going to go to second calc. Number 4 is the maximum. So, left bound, obviously somewhere to the left, hit enter. Right bound, somewhere to the right, hit enter. Guess, nah. So, if I find it, notice the max 11.99999, let's get to the point. It's pretty close to 12. So it looks like x is 12. That gets me my max. So what I did is I graphed this into y1. Remember, if you need to, I'm not going to write it for you. You can take your own notes here. I'd suggest that you write your window down. What window did you use to get that? So what are the best dimensions? Well, I know length by width are the dimensions. So 12 inches by, if I plug in 24 minus x, so 24 minus 12, and that's also 12 inches. So in this scenario, it turned out to be that actually a square was the best dimensions to have. Okay. Next problem. Take a second, read that to yourselves. Alright, so it says a farmer wants to make a rectangular enclosure. He wants to maximize the area of the enclosure. What should the dimensions of the enclosure be? The advice that I could definitely give you would be to make sure you, like we did before, draw a picture. So it looks like I got the wall on one side. I got 3 sides of fencing that I have to enclose. Obviously, I wouldn't want to put a fence where the wall is. That's just kind of a waste of money. So we want to maximize the area of the enclosure. Think about what we did last time. I always want to start with, well, I want to label that side X. If that side is X, that means the other side also needs to be X. I have 120 meters total. I know those 2 sides are X. So I know that last side is 120 minus 2X. Think about it. I don't need to divide that by 2 in this problem because I only have that side left. I'm not enclosing the wall side, so I don't need to divide that by 2. So when I find the area, I get length times width. So x times 120 minus 2x. If I think about that, I know I'm going to go to my graphing calculator to find the maximum area to enclose. So if I go to my graphing calculator, I'm going to go to y equals. Notice that I have that next one in there already. Little piece of advice, you can graph more than one function. Do you see how I'm right above the equal sign? If I hit enter there, now that equal sign is not highlighted anymore, it's not going to graph that function. If I go down to y2 and highlight that equal sign, now it's just going to graph that second function. So again, I'm going to zoom 6. I'm going to start with a standard window and go from there. So looks like my Ymax needs to get bigger. So in my window, for my Ymax, I'm going to make that bigger. I don't know, maybe 500, see where that gets me. Alright, not even close. Gotta get bigger than that. What about 1500? Alright, looks like that might be close. I know my X max needs to change. What if I made that 100? Is that too far? Alright, looks like 100 is good. I'm not quite at the max yet for my Y. I don't know. Maybe try like 2200. Alright, voila, there it is. I know I'm going to find the max, so same deal. Second calc, the max, left bound, somewhere to the left of it. Hit enter, right bound, somewhere to the right. Hit enter again. Looks like my max is 30. My x value is 30. So I found that x was 30. It said, what should the dimensions of the enclosure be? Well, that's length by width. So 30 meters by 60 meters should be that will maximize the area of my enclosure. All right, last one, letter J. Read that, take a look at it. Biggest thing you're going to need to understand, we're talking about income. How do you make money? Well, you take the price of whatever it is that you're selling times the number of items that you sold. That's how you make money, right? Makes sense. So we're talking about magazine circulation. It looks like the price right now is $1.60 per copy. But it says for every 40-cent increase, they'll lose 10,000 readers. So my price would be $1.60 plus, because we're talking about increasing it 40 cents for every 40-cent increase, so that's what's going to change. We don't know how many 40-cent increases we're going to use, so it's 160 plus 0.40x. What about the number sold? Right now, 80,000. They will lose 10,000 readers for every 40-cent increase. So I think the number sold will be, well, it looks like 80,000 minus 10,000 x. You can, if you want to, you can FOIL this from here, or you can simply leave it like that and figure out what price per copy will maximize the income. Well, in order to maximize the income, guess what? I'm going to go back to my graphing calculator. I'm going to go into y equals, and I'm going to type that last function. Notice I already have it in my calculator. I'm going to hit zoom 6. I'm going to start with a standard window. Yikes. Looks like it's just kind of a straight line that goes up and it comes back down. Holy Moses, does it look like I'm going to have to get a little bit bigger. Actually, a lot bigger. So, because those numbers were so large, like 80,000 and 10,000, I'm going to try to go higher than 80,000. Maybe I'm going to try to make my Y max 100,000. See where that gets me. Alright, not bad. Make it a little bit bigger. What about 150,000? And look at that. Looks like that's going to do the trick. So, let's find the max. So, second calc. Max. Left bound. Enter. Right bound. Enter. Guess. Yeah. Looks like x is, it's close enough to 2. So I'm going to say I get x is 2. Nope, not a box. I want you to think about what that 2 represents. Hopefully you're saying to yourself, that is how many times we're going to apply the 40-cent increase. We're going to apply that twice, and that's going to maximize our income. So be careful. Look at the last sentence. Look at what I ask you to figure out. what price per copy. So I'm only asking you to figure out the price of that. So to figure out the price, I'm just going to look at the price function of that. $1.60 plus 0.40x. Well, I know x is 2. I'm going to raise it 40 cents twice. So 160 plus 80. It looks like the price per copy, I should start charging $2.40, and that's going to maximize my income. Alright, that's it for our notes. Hopefully, if you have any questions at this point, let's jot them down on your paper and simply fire those questions at me when you see me tomorrow. Okay, good job.